All right, so now we are doing the second problem, and it reads x squared, x squared minus a 49. Okay, so this expression is not written in standard form. So we're still trying to change this sum into a product. It is called sum, even though it's subtracting. Positive times a negative is a negative. So this expression is not written in standard form, which is the very first thing we need before we even start to put it into the generic rectangle. So standard form, if we forgot what standard form is just writing it as 8x squared plus bx plus c. Now I'm going to choose the same colors that we have in the past. Maybe this will help you. And a, b, and c are just coefficients. So what we would do in this case, we would write x squared. This is area system. We would write x squared plus 0x minus 49. Okay, because there's no nothing in the middle. So that's plus 0x. So these two are actually equivalent to each other. But we're going to use the bottom one because it's the one that helps us. So let's use this one. And then again, we create our generic rectangle. Okay. And we write the first term, x squared, on the bottom left, and negative 49 on the top right, negative 49. And so now let's look at the factors. And we say, okay, the factors of 1, because it's 1x squared, 1 times x squared. So factors of 1 are just 1 times 1, as easy as that. And then the factors of negative 49, well, we know one has to be positive and one has to be negative in order to get a negative number. So then we would have a 1 times 49, or negative 49, negative 1 times positive 49. Remember, we have to try to find all these different combinations. 7 times negative 7, and then negative 7 times 7, and 49 times negative 1, and negative 49 times 1. So all those different combinations when you have negative numbers. And so then we kind of see which one of these combinations will work in our case. And so it continues to, like, all these 1, 2, 3, 4, and we need to make all those combinations to find a sum of 0x. Okay, let's remember that this variant has to give us 49. Okay, so then it has to add up to 0. So let's look at, let me write that as addition. It has to add up to 0, okay? So let's look at all these numbers. We have 1, negative 49, negative 1, 49, 7, negative 7, negative 7, 7, 49, negative 1, negative 49, and 1. Well, in this case, our factors 1 and 1 make it easy for us because anything multiplied times 1 is just itself. And so which of these will give me a sum when I add them? Which of these will give me a sum of 0? That gives me 48. This, in fact, gives me these two, this one and this one right here. Negative 7 and 7 give me a sum of 0. So I don't even have to go through each combination. I can just realize that when I add these two numbers, these two factors, it would give us 0. So then we do, doesn't matter the way that we write it. So let's do x and x, 1 times x times 1 times x, and then 7x and negative 7 7x and we get, oh, 7. 7 and 7. My bad. 7 and 7, and one of them has to be negative. It doesn't matter which one because when you add them, it will give you 0. So then we multiply negative 7 times x, negative 7x, and then 1 times 7, 1x times 7, it's going to be 7x. And when we write the area as a sum in here to verify our product, we have 1x squared plus 7x minus 7x minus 49. We combine like terms and we get area equals 1x squared minus 49, or x squared minus 49, same thing. So there you go. We have our area as a sum, which is the same as that one right there. And the way that we would factored form would be x plus 7 and x minus 7. I'm actually getting what we have right here. X plus 7 and x minus 7. That is my area as a product. Let's see. This is what we are looking for. Okay. All right, and we're done with that one.